Hello everyone. My name is Glenn Monson, and I'd like to apologize first. Got a little cold, so if you can't understand me, let me know. So first off, I'm going to do question number 3. It says, from the displacement equation, find the amplitude, wavelength, period, frequency, wave velocity, and maximum particle velocity and acceleration. And then make a history graph of position x equals 0. So the very first thing, to find the amplitude, that's just the meters. So that's the easy part of the problem. So we found, I'll just write everything on here. So if you can see that, amplitude is equal to 3 centimeters. So the next thing it wants us to find is the wavelength. And so in order to find this, we need to use our k value, which is given by the x. And so the one thing that you have to remember though is, so equation, you have this, so you have the sign of, you need to remember this pi here because that's going to be times through everything. So your k value is actually going to be 75 times the pi. So the equation that we use for this is k is equal to 2 pi over lambda. And then we can solve for lambda, which is equal to 2 pi over k. And we use our k value of 75 pi. So we get 75 pi. And that comes out to be 0.0267, and the units on that is meters, because is in radians per meter. So next we find the period, and it's kind of the same thing for finding the wavelength. You have to use your omega. So we use the equation 2 pi over omega to our period. So this equation right here, 2 pi over omega. And our omega is going to be the 2.5 t. We get it from that. But remember, you have to times it by pi, because that's times through everything. Pi over 2.5 pi. Your pi's can cancel, and you end up getting 0.8. And same thing with omega, that's in so you end up getting 0.8 seconds for your period. Next is the frequency, which that can be found, it's just 1 over t. So you just take what we just found for a period of 0.8 seconds and you divide 1 by that. So frequency, is equal to 1 over t, so 1 over 0.8. And that will give us 1.25 hertz is what the units on that are. Now the velocity, we can use the equation frequency times lambda, or wavelength. And I feel like that's probably the easiest, that we can just use that because we already found our frequency length. So our frequency was 1.25, and we times that by our wavelength, which was 0.0267 meters. And doing that will give us a velocity of 0.0334 meters per second. So there you go. So that's how you get the velocity. So I'll just leave that up there in case anybody's falling behind. They can look over it really fast. So the next is finding Vmax, which Vmax is equal to our amplitude times our angular frequency. I think that's what omega is. So our amplitude is 3 centimeters, but I'm going to put it in meters. So it's going to be 0.03 meters times omega, which, if you recall, that's the 2.5 t that comes from that. We have to do 2.5 times pi. So you get that. Vmax is equal to a omega, which is 0.03 meters times 2.5 pi. And that gives us 0.236 meters per second as our max velocity. And then it's the same process pretty much for max acceleration. Amplitude times omega squared, which our amplitude again is 0.03 meters. And again, omega is 2.5 pi. Make sure to square that like so. And that will give you 1.85 meters per second squared for our max amplitude. So there's everything on there you may need. See that? Now, it asks us also to do a when x is equal to 0. You take your equation of dxt is equal to 3 centimeter sine of pi times 75x minus 2.5t plus 1/6. So you have your equation. So here's your x. So if you just put a 0 in for there, that'll all cancel out here. So then you're just left with negative 2.5t plus 1/6. So the equation that we're going to be graphing is equation dt is equal to 3 centimeters sine. I'm just going to put the pi through so it's easier for me. Sorry. 0 because of the t, so 75 pi t, but t is equal to 0. So that's canceled out. 2.5 pi plus pi over 6. So it's going to look something like this. So 3 centimeters sine 75 pi x, but the x is 0, so that cancels out. Negative 2.5 t plus pi over 6. And so we know that our amplitude is going to be 3, and it's also going to go all the way down to negative 3. We know that our period is going to be 0.8 seconds. So between each pump, there's going to be 0.8. So with so the phase change is pi 6, so it's going to turn out to be something kind of like this. And then, so if you see on there, sorry, you have 3 centimeters for a max, and negative 3 down here is what up to for the amplitude. And then our wavelength should be 0.8, so something like 0.2 to 1, something, I don't know, something like, say that, so 0.2 to 1, and that's your period. I'm not very good at drawing, so I went ahead and just graphed it in Mathematica, so it should look something more like that, where here is 0, and your phase change brings it back pi 6, and your amplitude is up at 3, and down to negative 3. So, and that's problem number 3. Now for problem number 8, I'll do another video after this. That way you don't have to watch all of this to get number 8. For watching, if you have any questions, just ask me in the discussion boards. I can answer back. If there is something that I did wrong, please let me know. Thanks for watching.